Hello class, this is a video to help you with constructing a Punnett square and properly filling it out. Okay, so if you needed help and so that come next class you're a little bit more comfortable with doing the Punnett square, this video will help you out really well. Okay, so let's get down to it. So brief review, right? The Punnett square deals with genes. So genes come in two pairs, either homozygous, meaning that they're both capital or they're both lowercase, right? Homo, or they have one capital and one lowercase pair, which means that they are hetero. So homo meaning same, hetero meaning different. Okay, and so once you have that, doing the Punnett square comes easy. So let's get to it. So Punnett square looks like this. Looks just like a window. Okay, and then you need two parents, and you need to know what their gene pairs are. Okay, so let's say that we have one parent that is a homozygous dominant. Okay, capital meaning dominant, and we have another parent who is a homozygous recessive. So what you do is you take one parent and it goes up here on the top, so it looks like that. Then you take the next parent and it goes on the side like that. Then you fill in the squares with the letters that line up with it. So here, right, we have a capital A right here and a lowercase a right here, so that goes into this box here, so it's gonna look like that. And you do so with everything. So A, capital A, lowercase a. Now each box represents a 25% chance that the kid will look like that, right? So since all the boxes are the same, we know that their offspring will have a gene pair of capital A, lowercase a. So they're going to have a 100% chance of being a heterozygous kid. Now how that kid looks like depends on the phenotype that we assign to the genes. Okay, so let's try another example with more detail, right? So let's say we have two dogs. We have a black dog and we have a white dog. So the black dog will be a dominant homozygous black dog, okay? And we're gonna assign black to have the dominant gene, which means that the recessive gene will be white. The white dog, okay, will have a homozygous white gene. Now we just fill that in, right? Parent goes on the top, parent goes on the bottom, or on the side, I'm sorry. And then we fill in like so. And again, all of the squares are the same, so that means that there's a 100% chance that their puppy will have this gene pair. And since this gene pair has one dominant, the capital A, and one recessive, the lowercase a, the dominant gene will always outshine the recessive, which means that their dog will come out looking black. So a black dog and a white dog, there's a 100% chance that their puppy will be black. Now let's try another pair. Same thing, we're gonna have two black dogs this time. This time they're going to be both heterozygous gene pairs. Now again, there's the Punnett square, and at this point in the video, if you want to pause it and try it for yourself, you can, and then press play again to see if you can do it correctly, and if not, just a little bit more practice, it'll be fine. So again, this parent goes here, capital A, lowercase a. This parent goes here, capital A. Oops, I'll just erase that real quick. Capital A, lowercase a. We fill in the boxes like so. Now here, you notice the boxes now have different letter pairs in them. Now we have to write out the different letter pairs, right? So we see that there's one box with one capital, with both capital A's, right? Two boxes with a capital A, lowercase a, and then one both lowercase a's. So again, each box is 25% chance probability that the offspring will look like that. So that means that the double capital A's have a 25% chance of showing up. This is 50 since two boxes, right? 25 plus 25 is 50, and then 25 here. Okay, so what this means is that there's a 25% chance that their dog will be black with a homozygous gene pair, 50% chance that the dog will be black but with a heterozygous gene pair, and a 25% chance that the puppy will be white. Okay, so just because they're two black dogs, there's still a good amount of percentage that their dog could be white. Okay, so I hope this video helps, and any other questions, you know how to email me. It's in the syllabus, and we will see you in next class.